So let's start with our day 2. Okay, so Devmita has a big question. As you said yesterday, the calculations that are being done on console panel are being stored in memory as well. Let's say I have used a variable called x1 in my actual code and I have stored few values in it. I want to check something else. So on the console panel, I did some rough calculation. While doing so, I used the same x1 variable by mistake, because of which the actual value is messed up now. I don't think you will get the actual values again, Devmita, because you overwrote x1 with something else. So the original contents of x1 is gone. I don't think you can retrieve that. Okay, but you can go back to the same codes and see what was the original value. So you can use the up arrow key in the console and go back to the previous code, or you can look at the history tab on the right hand side top corner. Yes, Devmita, probably yes. It's a yes, because you overwrote your file, right? I think that is true for any language. If you define x1 is equal to 2, and in the next step if you define x1 is equal to 4, then the original value of x1 is lost. You will not be able to retrieve the original value of x1. Okay, but if you want to see what was the value you assigned, you can go back. You can use the up arrow here. You can go to the console and use the up arrow key. So see, right now I'm pressing the up arrow key, and whatever codes I previously used, that is all coming here. So these codes you will not understand. These are all modeling part, which we will come to later. But this is how you would go to the previous codes. Okay. Okay. So let's do a revision of yesterday. So what did we see yesterday? We saw the first data type. We saw how to set the working directory, right? We saw how do we retrieve the existing working directory and how do we set the working directory. Okay, and we either use double backslash or a single forward slash. This is what we used while setting the working directory. Okay, so what's the purpose of setting the working directory? The purpose is that you can directly access the files which are in your working directory. You don't have to type the location. Okay, or let's say you want to save your R file. If you press Ctrl S, the R file will be saved with a .r extension. So this will be saved in your working directory. Again, if you want to save it at some other location, you'll have to give the entire location to save at a particular location. Okay, so this we saw. Then we move to the data types in R. The first data type that we saw was vectors. So we only saw one data type yesterday, which was vectors. So vectors are a collection of elements. Okay, vectors are a collection of elements, and the only thing to note here is all elements should be of same data type. You cannot have a mixture. You cannot have a floating number and a character together. Okay, all has to be of the same data type. Abhishek is asking data type or data structure. You can say they are data structures. Okay, data structures. So data types are basically floats, integers, character. These are called data types. These are data structures. Okay, my bad. These are data structures. Or very vaguely they are also referred as data types, but I think that is wrong. Okay, so that is vectors. Now what did we see? How do we define vectors? We define vectors using the C function, the small c function, and the first bracket. So whatever you write within this, separated by commas, are all the elements that will be in the vector. So let's say you define x is equal to c1 2 3. That means x is a vector in R which has three elements, 1 2 and 3. These are values of the elements. Okay, and we have the indexing thing in R. So the index of the first element is 1, index of second is 2, index of third is 3. Okay, this is the index. Okay, let's make it some other number. So you can also retrieve the elements by their indexes directly. So you can give, so for that we use the square brackets. We use square brackets for that. So if you have to retrieve the first element, you use x square bracket 1 if you want to retrieve the first element. If you want to retrieve the last one, you can use x 3. That will give you 30. This will give you 30 as the output. This will give you 11 as the output. Pretty simple. Okay. Just remember one, we use square brackets here. Okay. You can also use x of, if you want to retrieve, let's say both 2 and 3, then you can use c of 2 comma 3. See why we are using C here? Because whenever you use multiple elements, or multiple indexes, you will have to use the combine operator. Okay, because you are using more than one. If it is only one, you can directly use, but if it is more than one, you'll have to use the combine operator. So x c comma 2 3 will give you 20 and 30, because 20 is at index 2, 30 is at index 3. Okay. You can also use x minus 1 here. So what will this give you? Anybody remembers from yesterday? What will x minus 1 give me? And what will x minus 3 give me? Okay, so x minus 1 will give me everything except the first element. Okay, minus 1 means I'm omitting the first one basically. So this will give me 20 30. Yeah, and x minus 3 will give me similarly 11 20. So it will omit the third one and give me the rest. So that's how it works. Okay. So anything else? And we saw a few functions on vectors. So you can use a lot of functions on vectors. You can use the length of the vector. Length of a vector will give you how many elements are present in that vector. Okay. Similarly, you have max, you have main, and many other functions. We will see the functions as we go on using them. Okay. By end of the course, you would have seen almost 50-60 functions like this. Okay. Next, what did we see? Yes, guys, what else did we see yesterday apart from this? Okay. Anybody remembers what else did we see yesterday apart from this? Let me open up the Excel. Okay, the packages and then univariate analysis. Okay. So we discussed what are packages in R, right? So we discussed what are packages now. So anybody who thinks that he has come up with a function which might be useful to other people, they can publish a package. So even you guys can publish packages if you want. Okay. Mrityunjay, indexes is already done, right? Yeah. So packages, even if you guys feel that you have written a function which is very helpful and which might be of use to other people, you can publish a package with those functions. So there will be a team which will verify the package and whether it works correctly, and they'll ask you to prepare a document on that so that the document can be referred by anybody for the syntax and other things, and then you can also publish your package. There are around 5,000 packages in R. Okay, but not all is required. We hardly need 15 to 20 packages. We need functions which are present in 15 to 20 packages. That should be enough. Okay, so we saw how do we install packages. That was pretty simple. We just write install dot packages, and within quotes you write the name of the package, whichever package you want to install. So as of now we don't need any package. So whatever we have discussed so far, length, max, minimum, so these functions are present in R itself. You don't need any package for that. These are already inbuilt in R. But later when we go to machine learning, when we start with machine learning, then you will see that you will have to use a few packages, because the machine learning functions will not be directly available in base R. You'll have to go to some packages for that, and it's very easy. We will see that later. So that is how you install packages. If you want to see what are the packages already installed on your system, you can write installed.packages, the past tense. Okay, if you write installed.packages, you will get a list of all the packages that are installed. Okay, so that's what we saw. Then we move to descriptive statistics after that. Okay, We move to descriptive stats after that. So anybody remembers what is descriptive statistics? Yes, guys. What did we see in descriptive statistics? Yeah, the mean median mode, right? Histograms you can say, but actually it is mean median mode. Okay. So why is it called descriptive statistics? It is called descriptive statistics because those parameters, mean median mode, they are used to describe a population. They are used to describe a population. Hence, they are known as descriptive statistics. For example, what is the average income of an engineer in Bangalore? So you will have many engineers in Bangalore. You will use the mean or the median or the mode to describe what is the average income of an engineer in Bangalore. So that means you are describing the population using these three terms. Hence, it is known as descriptive statistics. Okay, that is why we call it a descriptive stats. So mean median mode. We already know what is mean. Mean is the simple average. Median is the 50th percentile. Okay, 50th percentile. That means 50% of people are below you, 50% are above you. Okay, so that is the median. And always remember, whenever you find median, first thing you have to do is to sort the numbers. Only after that you have to see which number is falling in the middle. It is not dependent on the order. Okay, you have to first sort it and then just take the middle number. So yesterday some of you made a mistake, right? So because you did not take the increasing order of it, you just look at the numbers and found which is in the middle. Okay, so median is not taken like that. You first sort them in increasing order and then pick which one is in the middle. And then mode, everybody understands, the most commonly occurring value is the mode. So this was about the descriptive statistics part. Next we move to univariate analysis. So why univariate analysis? When we analyze one variable at a time, then it's called univariate analysis. You might have many variables available to you. So imagine a SQL database where you might have many columns, right? You might have many columns, but you're not studying all the columns together. You are studying only one at a time. You're studying only one at a time. So then it's called univariate analysis. Uni means one. So how do we do univariate analysis? The first thing is you can go back and do a descriptive statistics. Okay, you can take the variable and find its mean median mode. So that would be doing a descriptive statistics on the variable. So that is also a part of univariate analysis. Other things that you can do is you can draw the histogram for that. Okay, so now what is a histogram? You can tell me. Yes guys, what is a histogram? Yes, so it is a graph which shows you how is a variable distributed. Okay, yeah, Mauli, that is a usage of the graph. Okay, that is a usage of a graph, but the graph is basically, it shows you how is a variable distributed. So let's talk about again uh, the salary of an average engineer in Bangalore. So if you go to descriptive statistics, yes, Demita is right, graphical representation of the distribution. So let's say the income of all engineers in Bangalore. Okay, so if you go to descript, why histogram is better than doing a descriptive statistics? Why is that better? So if you do a descriptive statistics, you might have, let's say, the income of many engineers in Bangalore. Okay, let's say these are the engineers and you ask the income of everybody, but the moment you take mean or the median or the mode, you get one single number, right? You get one single number for mean, one single number for median, one single number for mode, but you don't capture everybody. you are like the average. If you take the average, it will be somewhere in the middle, but it still is different from the salary of everybody. So you lose a lot of information in that case. But if you take a histogram, you don't lose any information. Okay, you don't lose any information in histogram. You will basically take care of, you will take into consideration everybody's salary. You will not lose any information. Okay, so the x-axis of a histogram is the variable into consideration, whatever is the variable. In this case, let's say the salary of all engineers in Bangalore. And what do you have on the y-axis? Yes, we have the frequency on the y-axis. Okay, frequency or the count. Okay, so let's say if I give the salaries of, let's say, 10 engineers in Bangalore. I just counted for 10. So these are the 10 engineers. Okay, let's say his salary is 3, his is 4, his is again 3, his is 4, his is 6, 9, 11, 8, 6, and this is, let's say, 15. So these are the salaries of all engineers in Bangalore. Okay, so if I have to draw a histogram of it, I will just start with the count. So the minimum I see is 3, so I'll place 3 here. The maximum I see is 10, so I'll place 10 here. No, 15, so I'll place 15 here. Now I will count how many engineers have a salary of 3. So if I count that, it will be 1, 2, yeah, only 2 have. So the height of this bar here will be 2. So let's say this is 1, this is 2. This is 1, this is 2. Okay, the height will be 2. Next I will go to 4. So 4 here. So 4, how many? 1, 2. Again 2. So the height here also will be 2. So it will match with this basically. They both will be of the same height. And the breadth also will be same. Okay. So my diagram is not perfect. The breadth will be same. Then similarly you will look for 5. There are no 5, so height will be 0. 6. You will come to 6. There are 2 engineers with a salary of 6. So this also will be height 2. 7, there are none. 8, there is 1, 8. So 7 will be a blank, and 8 you will have a height of 1. Okay. Then 9, you have again 9, height of 1. 10, there is no 10. 11, you have 1, 11. So 10 will be a blank and 11 will be 1. And then straight away you have a 15. So at 15 you will have another 1 height. So this is the histogram of these 10 engineers in Bangalore. This is the histogram. So this is the frequency or the count, and this is the variable. Okay, so it tells you that 3 lakhs or 4 lakhs, there are 2 engineers with this. So this is 1, this is 2. There are 2 engineers with this salary, 2 engineers with a salary of 6, 1 engineer with a salary of whatever this is, 7, 8, 1 engineer with salary 10, 1 with salary 15. So you don't lose any information. This is like taking the entire information here and plotting it. Okay, you don't lose any information here. And we saw how do we plot this in R. We use the hist function. Okay, hist, and so this salary of everybody in Bangalore will be stored as a vector. So you can write salary and you can give 10 numbers separated by comma. So 3, 4, 3, 4, 6, and so on. Okay, and you will just write hist of salary. Then you will get the histogram for this. Okay, now the histogram, let's say sometimes histogram, what you will see, the histogram will just count these 3 together. Okay, let's say the salary ranges from 3 till 3 crore. You might have people who are earning 3 crores in Bangalore also, right? So a Vishal Sikka or any CEO would be having salary close to this. So this axis will be very big. This axis will be very big. In that case, you cannot go 1 unit at a time. You cannot go 3, then 4, then 5, then 6. So if you go that way, you will not find enough space here to see the histogram. So in that case is what is done, you basically form groups here. So you will form groups here. You will say that this point is, let's say this point is 100. This is, let's say, 200. This is 300, and so on. So you will go in increments of 100. Okay, 300, 400, and so on. If you have to go to a big number, okay, you will go in this way. Or if you have a even bigger, you can go in thousands. So this is, let's say, when I say 100, it's 100 lakhs, okay, it's 100 lakhs. Or let's say it's 10 lakhs, 10 lakhs, 20 lakhs, 30 lakhs, 40 lakhs. So if you go in this way, you might reach 3 crore pretty soon. So this is how you will group it basically. And if you group it, how will these counts vary now? Now if you write 10 lakhs, all these guys, they fall between. So this 10 lakhs means it is from 0 to 10, okay. Similarly, this 20 means it is from 10 to 20. This 30 means it is from 20 to 30. So this 10 means all guys who have a salary between 0 to 10 will be included here. So that means each of these will be included. So you will just add them. You will just add them. So how many you have? 2, 2, 4, 5, 6, 7, 8, 9, 10. So the height will increase to 10. The height will increase to 10. You will just aggregate them together and you will get the height of 10. Okay. And similarly, you will go ahead also. Is this clear, guys? So how do you decide this grouping thing? The grouping that we did, how do we decide that? We decide that by using the breaks parameter. Okay. We give breaks is equal to some number n while we run this command. So you can run hist, you can run salary, and you give breaks is equal to some number. So the larger the number you give, the smaller these divisions will be. Okay, the larger number, if you give 100, if you give 100 here, that means there will be 100 divisions in the data. If you give 10, means there will be only 10 divisions. So you will have these groupings happening. So you can play with that. Okay, you can play around with that. So Devmita has a question. The count person having salary 10 lakhs will be included in. No, it will not be included, Devmita. It will be included in the first one. Okay. So 0 to 10 means from 0 till 10, including 10. And 10 to 20 means not including 10. So 10 plus till 20, including 20. It goes that way. It will not be included in both sides. Okay. It will only be included on one of the sides. Okay. Otherwise, it will become difficult to understand and interpret, right? Only on one side it will be included. But R takes care of that. So we don't have to worry about that. R takes care of that. Yes. So it depends. Some softwares, they will take upper limit inclusive. Some softwares, they will take lower limit inclusive. But it is really not a worry for us because it will not consider on both sides. That is for sure. Okay, it won't consider on both sides. Now whichever side it is considering, that is not a concern because we anyways will look at the height and then we will interpret. So we are not concerned which side that person go, as long as we know that it is going only on one side. Okay. So this is about histograms. Now we also talked how histograms can help us decide whether there are outliers in the data or not. Okay. So imagine if you draw the histogram. Okay, first let me show you. Let me just quickly draw a histogram and show you. So this was yesterday's file. Let me create a file for today. Guys, are you following? Everybody? Anant, are you following? Okay. So first I will create some. Okay. First I will create some random numbers. Okay. So random numbers, we haven't seen this function so far, but this is how you create random numbers. Okay. Let me create, let's say, 5,000 random numbers. So this function will give me 5,000 random numbers. So I'm creating 5,000 random numbers, and it will create random numbers between 0 and 1. So I have created 5,000 random numbers. Don't worry about the warning I get. Okay, my our version is very old, which is why I get these warnings. So, and then I will plot the histogram. So if I plot histogram, I will plot it for those 5,000 variables, and this is how it will look. So this is how it is looking. Okay, so see, I hardly have a few bars here. So let me increase the divisions that it is being done here. So right now I have 1 2 3 4 5 6 7 8 9 10. I have 10 divisions only in my data. Let me make it even smaller. So let me give break is equal to, let's say, 40. Okay, now you see I have finer bars. Now my bars are even finer. So I get more information now from the histogram. Okay, and of course if I want I can add colors as well. Okay, I have finer bars in my data now. So this might be the, let's say, this might be the salary of a engineer in Bangalore between 0 to 10 lakhs, let's say. Okay, so the distribution might look something like this. And how will you identify the mode here, guys? So we haven't talked about mode yet. How will you identify the mode here? Anybody want to make a guess? From the histogram, can you identify the mode, or it is not possible? Yes, so Ravi is right. The tallest axis. I think Debmita also wanted to say the same. The tallest bar here represents the mode. So this, so not the value of the taller bar, not the value on the y-axis. Okay, the value on the x-axis will be the mode. But which value on the x-axis will you take? That you will take the value corresponding to the tallest bar. So this is the tallest bar, right? So if you come down here, this will be the mode of this variable. So the mode is somewhere here. So 0.1, around 0.1. That is the mode. Okay. So this taller bar, this tallest bar corresponds to the mode. So this is the mode here. So this probably is 0.1. Okay. So the mode of this variable is 0.1. Okay. And if you want, you can add labels also. Let's say right now it is histogram of random numbers, right? If you want, you can give some labels also. For example, if you want to label on the x-axis, you see I'm using the IntelliSense. Okay, so x lab is equal to, so right now this just has random numbers written. So what you can do, you can just write something whatever you want. Let's say x-axis, you can write x-axis. Similarly, you can give y label also, the same syntax. Okay, it's very simple. Ars IntelliSense, if you use, you don't have to memorize anything. You can write, let's say, count or frequency. Okay, so this will give you the labels. So now you see, instead of random number here, you are getting x-axis. Instead of what you were getting earlier, now you have count frequency. And you can add a overall title also. If you want to add a overall title, so that you add by using main. Main means the main title. So you can write my first histogram. Okay, so now since this is in two lines, I'll have to select both the lines and then press Ctrl Enter. So I'm getting the labels that I have given, basically my first histogram, x-axis, and this y-axis. Okay, so this way you can give your own labels, and then if you want, you can save that also. So you can save it as PDF, PNG, whatever format you want. You can save the files also, and we do this a lot. Okay, because in industry you have to make presentations and all. Whatever you have done, you'll have to present it to your customer or to your client. So you will use these plots also. So you will save this, put it in a PPT along with other results, and then you save it, send it to the client. So that's all about histogram. Now how will a histogram help us identify missing values, not missing values, sorry. How will it help us identify outliers in our data? So we discussed what are outliers. So what are outliers? Who can tell me? Yes, guys, what is an outlier? Yeah, you can say rarely occurring strange value, right? Yeah, so Devmita's definition is good. Data that is different from most other data. Okay, so let's say you appear in a test and everybody has scored around 50, 60, or less than 70. Everybody has scored between 30 to 70, and there is a guy who has scored 99. So of course he's an outlier, right? So outlier doesn't always mean that that value is bad. It might be very good also. It might be very good or it might be very bad, but it is totally different from the remaining things. That is why we call it an outlier. Okay. So how do histograms help us identify outliers? If you have outliers in your data and if you draw a histogram, you will see a tail like this. The histogram will be like this. So that means that you have outliers in your data. Okay. So if you see this kind of a structure, so for example in our histogram we did not see this, so there were no outliers there because all the values were between 0 and 1, so there were no outliers. But here you see, let's say this is 1, this is 2, 3, and then you have, let's say, 8, 9, 10. So value 1 is occurring these many times. Let's say this is 50. So value 1 is occurring 50 times, right? That is why the height is 50. Value 1.5 is occurring even more number of times, more than 50 times. Value 2 is occurring again around 50 number of times. 3 is occurring around 40 times. So 40 times 3 is occurring. That means it is not an outlier because it is occurring 40 times. Okay. But if you come here, so value 10, it is occurring only once. So this height is once. Imagine this height is once. Okay. So value 10 is occurring only once. Similarly, value 9 is occurring only once. Value 8 is occurring maybe twice. But these values are occurring 40, 50 times, right? And these are occurring only 2 or 3 times. So that means these all are outliers. They are occurring very rare in the data and they are very huge as well. Their values are also big compared to them. So these are like outliers in the data. Okay, and outliers always occur very few number of times. They won't occur a lot in your data. They will occur very few number of times. Okay, so histograms help you identify such outliers. Later we will see another plot called box plot, which will directly give you what is an outlier and what is not. But this gives you an idea. It will not directly tell you, but it gives you an idea. Opposite to mode in a vector, yes, Lalita, you can say that in a way. In a way you can say that it is opposite to mode because outliers occur very rare in the data, so the frequency should be very small for outliers. So if you can say in a way that it is opposite to mode. Okay, because mode means it should occur more number of times and outliers occur very less number of times. Okay, so later we will see a plot called box plot which will directly tell us which is an outlier and which is not. So right now it is kind of vague. So for example, I told you that these three are outliers. Some people may say that this is also outlier because this also occurs only 4 times. So how do we decide which is outlier and which is not? Where do you set the limit basically? That whatever is occurring less than 5 number of times is outlier, or whatever is occurring less than 4 number of times is outlier. So it's kind of vague here. Okay, so from a histogram you will not get the exact number. You will get an idea that okay, there are outliers. But that exact number you will get from box plot, which we will see later. Okay, we will see that later. But histogram gives you an idea kind of. But box plot will clarify all the missing points of a histogram. Okay, now we also talked about the difference of mean and median in a histogram. Let's say this is a histogram. So when I draw a histogram like this, it actually are small bars. Okay, they are actually small bars. I have just drawn a curve over them. Okay, so that is what I mean. So for example, if this is the histogram, so what I have done is, instead of drawing the histogram like this, it will require a lot of effort to draw like this. What I have done is, basically I have just drawn a curve over it. So if I draw a curve over it, it will look something like this. So this is how the histogram looks like. Okay, so that is how the histogram is looking like. So this is my histogram, you can see. Okay, so this is my histogram. This is how the histogram looked like, exactly like this. Okay, okay, so imagine this is a histogram. Now where do you think the median lies in this histogram? Let's say this value starts from 0 and goes till 100. So I'll give you two conditions and you tell me which is correct. Okay, so mean is less than median, or mean is greater than median here. Which one is correct? In this histogram, which one is correct? One or two? Okay, so everybody is correct. The second one is correct. Okay, why the second one is correct is because, see, let's say, imagine these values are 1, 2, 5, 9 and 100. So what is the mean in this case? The mean will be 1 plus 2 plus 5 plus 9 plus 100 divided by 5, which is 9, 10, 7. 107 divided by 5. Okay, so 21.4 is the average. And what is the median? Yes, Jagdish, what is the median here? 5. Okay, so the median is 5, the middle number. So see what happened here. This was like an outlier to me, right? Because this value was very different from the other values. So what happened? Since you added this value also to the mean, the entire sum became huge and the mean got pushed towards the outlier. The mean increased just because of this guy, but the median was unaffected by 100. You did not even see what is that value. Even if it was 10,000, or no matter how many zeros you put here, your median will remain the same. But will your mean remain the same? No. If you put 2 3 zeros here, it will go into thousands, right? So what does this mean? This means that your average is affected by outliers, but your median is not. Okay, your average is affected by outliers, so this is affected, but this is not affected. This is not affected by outliers. And what do we see here? We see a few outliers here. So what will happen? The average will be affected by these outliers and it will become more. So that means this will be true. The mean will be greater than the median. The mean will come somewhere here. Okay, and the median will still be here. The median is always less than the mean when you have outliers on the right hand side. Okay, this kind of histogram is known as right skewed histogram. Okay, this is known as a right skewed histogram, where you have outliers on the right hand side. And wherever salary is concerned, wherever salary or income of somebody is concerned, you will always see a right tail histogram. So take for example the income of an engineer in Bangalore. It will start maybe from 2 lakhs but go all the way till, I don't know, there must be some people working in Google who might be earning, let's say, 10 lakhs. Not 10 lakhs, sorry, 1 crore. So you'll always see a right skewed histogram. So wherever money or income is concerned, you will see a right skewed histogram most of the times. Okay, And when you see a left tail histogram, so for example, premature childbirth, if you see, you will see a left tailed histogram. Okay, so most of the childbirth it takes after 9 months, but a few cases you will have maybe after 6 months or 5 months, the baby being born. So there you will see a left tailed histogram, but these are very rare. Rarely you see a left tailed histogram, mostly you see a right tailed. Okay, so that is why in this case your average is greater than the median. Now if I have to tell you in another way what is median and what is average in case of a histogram, the median is the 50% area. Wherever you get the 50% area, that is your median. Okay, because median, if you know, it is 50th percentile. 50th percentile is nothing but 50% below you, 50% above you, and this area represents the total number of person. Okay, the area represents the total number of person in that thing. Okay, so 50% and 50% above you. But where is the mean? The mean is always where this particular shape will balance each other like a seesaw. So because there are a few guys who are here who are very far, this plug has to be put on their side. Okay, so that is why this will be where this balance is. Maybe somewhere here it will be where this will balance each other. Okay, so that's the difference between mean, median in a histogram, and how they are affected by the 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 outliers basically. Okay, cool guys, till now. Okay, uh, what else did we cover? Anything else yesterday? What else did we cover yesterday apart from these? So after every Sunday's class, I'll be sending out this Excel to everybody, which will have all the topics that were covered and the YouTube link also. Okay, after every Sunday I'll do that. So indexing is done. Univariate analysis, histogram. Okay, so that is all that we covered yesterday. Okay, so now we can move ahead with today's topic. So any doubts, guys, so far? So tell me if you have any doubts, or we will start with today's topic. So we have already started actually. We covered a few new things today that was not covered. Okay, so let's first do a little bit of R portion also. Then we will come back to statistics and further explore it. But little bit let us go back into R because we have to learn R simultaneously. Okay. So let's look at the next data type. The next data type, which is matrices or matrix. So matrix in R. Let us see what are matrix in R. Okay, so matrix is very similar to a vector, but it is in two dimensions. Okay, it is in two dimensions. It is very similar to a vector. So how do you define a matrix? We define a matrix by using the function called matrix. Very easy to remember. You just use a function called matrix and then you give the values that you want in the matrix. Let's say I want the values 1 till 10. Okay, I want the values 1 till 10. So let's say this is how the matrix looks like. Okay, you have some rows, you have some columns. So what details do you need to form this matrix? What are the details that you need to create this matrix? First is what elements do you want? What are these values? What elements do you want? So that information I have given. Next is how many rows do you want and how many columns do you want? Right guys? These three information you need. What are the values in the matrix? The rows that you have in the matrix and the columns that you have in the matrix. Okay, so this is what we give here. First we give the values that we want, then we give the rows that we want. So we can give that by using n row. N row is equal to, let's say, 5. I will give n row is equal to 5. Now if I give n row is equal to 5, Do you think I have to give the number of columns also? Is that mandatory? What do you think? Do you think if I give the number of rows, I have to give the number of columns also? Why no? Because it can automatically take, right? Because rows into columns is equal to number of elements, right? Yeah, that's what somebody is telling. The Disha is telling that. Okay, because rows into columns is the number of elements. So if you have given number of rows, there is no point in giving number of columns. You can give if you want, you can give 2, but you can omit this also. This is optional. And if you give this, you will get a matrix. So 1 2 3 4 5 6 7 8 9 10. This will be your matrix. Okay, let us do this in R quickly. So we are looking at the second data structure, which is matrix. So let me define a matrix. So I'll use the matrix function. I'll use the IntelliSense of R. I will give 1:10. Okay. Then I will use n row is equal to 5. So I ran this. Now I will just print my matrix X. So you see I'm getting the matrix. Okay. So I got the matrix. Now you might have a question. Okay, there is some issue in my R. I'm getting the output twice. Even though I'm running it once, I'm getting the output twice. I'll have to restart it to fix this, but that's okay. I'll leave it as it is. Okay. So don't worry about this. You won't get it twice. There is some malfunction in my R. So this is the matrix. I'm getting 1 2 3 4 5 6. Now you guys might have a question. Somebody might ask me that why did I get it like this? Why didn't I get it like this? Right? I could have got the matrix in this way also, right? Why did I get it in this way? Why was 1 2 3 coming as a column and not as this? So that is because by default R does this. Okay, by default R will do this. So if you have to change that, you will use by row is equal to true. So when you give by row is equal to true, what does this mean? This means you want the rows to be filled first. By default this is true. Okay, by default by row is equal to false, but here I'm intentionally making it true. That means I want the rows to be filled first. So I will get 1 2 in the same row, not like this. Okay, I was getting the same thing earlier. No, I was getting this earlier. It came twice. Okay, so previously I was getting 1 2 3 as in columns 1 2 3, but now I am getting 1 2 in the same row, then the next row is starting. So that is controlled by row parameter. Okay, is that clear, guys? Let me restart R. Okay, I'm getting the outputs twice. So how do we restart R? There was an option somewhere. So let me restart my R. I'm getting outputs twice. Was it in session? Okay, I missed it. Yeah, it's here. Okay. So yeah, it's running once now. So clear now till here? Matrix. How you can change the matrix? So you can give any numbers that you want in the matrix. Now let me ask you something. Let's say I give this matrix, the same matrix I am creating now, And by the way, did I forgot to mention? I forgot to mention that matrix will also have the same data type always. Okay, because I mentioned it is like vector, so it will have the same data type. You cannot have two data types in a matrix, just like vectors. It is exactly same as vectors, but in two dimension. Okay. So now the question is, if I give, let's say, 1 is to 10, and if I give n row is equal to 5, and let's say I intentionally give n column is equal to 3, what will happen? Now 5 into 3 is 15, but I have only 10. So what will happen? Yes guys, what do you think will happen? Okay, Disha says it will fill with 0. Ravi says error. Jagdish says blank. Let's see. Let's see what happens if we do that. So I will create another matrix x2, which is matrix 1 is to 10, n row is equal to 5. Oops. And let's say I give n call is equal to 3. I am getting a warning, but I'm not getting an error. Okay, warning is different than error. Warnings you can ignore, but error means that code has not run. But warning means it has run, but it is trying to warn you. So let's say what warning it is giving us. So warning message in matrix, this one, whatever we have created, data length is 10, is not a sub multiple or a multiple of the number of columns. So whatever we expected will happen has happened, but the only problem is the code ran. Not a problem, but the code ran, but it is trying to warn us that you are doing something which might be wrong. So R is trying to warn us, but it is not throwing an error. So let's see if we print what happens. If we print x2, so can somebody tell me what's going on here? What value did I get? I did not get any 0. So you guys mentioned that you will get an error. I did not get an error. Somebody mentioned it will be filled with 0. It is not filled with 0. Somebody mentioned it will be filled with blank. It is not filled with blank. So what has happened here? Can somebody understand what went here? Yes, exactly. The moment you do something like this, R will start repeating the numbers again. Yes. So what happened? 1, 2, 3, 4. The numbers got finished here. Now after that what happened? The numbers started repeating again. So that's what happened if you do something like this. Even if I gave n call is equal to 4, the same thing would happen. It will start repeating. So 1, 2, 3, 4, 5 and again 6, 7, 8, 9, 10. It will start repeating the numbers again. So whenever you are dealing with matrices, be careful of this. Okay. And see, this time it did not give me a warning. The next time when I ran it, it did not give me a warning. But the first time it gave me a warning. Okay, so R thought that this guy is pretty stubborn. I'm giving him a warning, but still he is running the same code. So I guess he is doing it intentionally. That's what R thought. And the second time it did not give me a warning. So it will give a warning only the first time you are trying to write something which might be wrong. The second time it won't give you a warning. Okay. So be careful when you are doing things like this. You'll have to be careful of the lengths. Otherwise R will start repeating. Oh, sorry, I had muted myself. Okay. So what I mentioned was, yeah, I went on mute. I did not realize it. So what I was telling is, if you have a vector, let's say this is a vector, okay. If you have to multiply every element in a vector by 2, you can just write the name of the vector into 2. Okay, the asterisk into 2. So that will give you 2, 10, and 18. That will multiply each element by 2. You don't have to create a loop and then multiply individual single elements one at a time. You don't have to do that. Okay. Similarly, if you have to add 2 to each element in a vector, you can just write x plus 2. So that will give you 3, 7, and 11. Okay. And the same is true for a matrix also. So let's say this is our x2, right? Let's say I want to multiply every element in this matrix by 2. So I will just write x2 into 2. So see, it has multiplied every element in that matrix by 2. Okay. In some languages, you cannot do this. You will have to create a loop and select individual elements at a time and then multiply. But in R, it is not required. You can directly do a operation like this on matrices or vectors or other data types also. Okay. So that's about matrices. Now we saw indexing in vectors, right? Let us see indexing in matrices also. We can do indexing in matrices also. Now it is in 2 dimension, right? So indexing in 2 dimension. So how do we do that? The same funda we will use. Earlier we were writing x1, right? Now if we write, let's say I give the matrix and I give x2 1, it is giving me 1 as the output. Just a minute. This is my x2 and x2 of 1. It is giving me 1. So this number it is giving me. What if I write 2? It will give me 2. Okay, so by default it is assuming it is 1. Okay, so what you have to do is, if you have to access any element from this matrix, what do you need? Two things basically. One, you need the row number of the element that you want, and then you need the column number of the element that you want. That is how you would do it in maths also, right? So R is very similar to maths. In fact, R is a statistical language. Okay, so whatever you would do in mathematics or statistics, you would do the same thing in R also. So let's say I want 2 as the output. So which row is it present in? It is present in the second row. So I will give 2. And which column is it present in? It is present in the first column. So I will write x2, then 2 comma 1, and I will get 2 as the output. Okay, so that is how you will index a element from a matrix. Okay, is it clear, guys? So let's say you have a matrix like this: 11, 21, 13, and 7. If so, this is row number 1, this is row number 2, this is column number 1, this is column number 2, and let's say the matrix is x. So how will you get 11 out of it? You just write x, same square brackets that you use for indexing, but since you are in 2 dimensions now, you will have to give 2 inputs separated by comma. The first input is the row that you want, so the first input is always the row number. Okay, and the second input is the column number that you want. So I want the first row and first column, so I will write 1 and 1. Okay, so if you have to get 7 out of it, you will write x 2 comma 2. This will give you output of 7. Okay, is this clear, guys? Okay, now let's assume that you have a very big matrix. Okay, so this is row number 1. Let's say you have 100 rows here, and these are all some values. Now if I tell you let's say I want all of these, I want all of this. So how will you do this? You will write x, you will write all the rows that I want, and then you will write column number. The column number is 1 here. You will write the column number. But it is not possible for you to write all the numbers from 1 till 100. Okay, So what you can do in that case, if you want everything, you will just leave it blank. You will just leave it blank. So the moment you leave it blank, it means you want all. It means you want all. If you leave it blank. So if you leave the row number blank, it will print all the rows. If you leave the column number blank, it will print you all the columns. So let's see this in R. So this is for second column, second row and first column. Okay. Similarly, to get all rows, what you will do? You will write x2 and you will just give a comma and you will write the column number that you want. Let's say I want to get all rows in first column. To get all rows in first column, you will print this. So x2, first let us print x2. What is x2? So this is our x2. Okay. This is our x2. If I want all the rows in the first column, I'll just run this. This will give me all the rows in the first column. And the output is a vector. If you see the output of this, the output is one dimension. This is a vector, okay? So this will have all the properties of a vector. You can take the sum of it, you can take the length of it, and so on. So this output, so whenever you get this one written here, that means it is a vector. The output is a vector. Okay, so this is a vector. So if you have to check the class of x2, you will get matrix. But if you have to check the class of x2 and 1, that will be a vector, so it will show integer because it is a vector of integers. So it will show you integer. Okay, so I have left this blank, means I want all the rows. Okay, similarly if you want all the columns, all columns in third row. So what will be the formula for this, guys? If you want all the columns in third row, yes guys, yeah Vagish, but you will have to mention the name of the matrix also, right? So x2 is the name of the matrix. I want all the columns in third row. So third row, and I'll leave it blank. I'll leave the column number as blank. Lalitya, you have given first bracket. It is not first bracket. Okay, it is the third bracket. Square brackets. Always remember that. Yes, Jagdish, you are right. And print option is not mandatory, Mitrunjay. You can just run. It will print in the console. So I got 3838 when I ran this. Okay. So this is how you do indexing in a matrix. And now if I print the matrix and show you the output, now you will understand what these terms mean. So you would have seen these, right? And you would have, maybe some of you would have had this question, what are these numbers? So these numbers are representing the same thing. What does space 1 means? Space 1 means all the rows but first column. Similarly, space 2 means all the rows second column, and so on. Similarly here, first row all the columns. So this is nothing but first row all the columns. Similarly, this is nothing but fifth row all the columns. So you have these written here. These are identifiers for the column and for the rows. Okay, is that clear, everybody? Now you can give names also to the columns. Okay, so you can also write column names of x2. You can give some names if you want. So since we have 4 columns, I'll have to write 4 names. So I can write A, B, C and D. And then if I print x2, I will have column names instead of those numbers that we saw. So now I have column names. So this also you can do. You can use the column names function. Okay. So I have used a function called call names, which is nothing but it is used to give column names to a matrix or to a data frame, which we will see later. Okay. So now if you print, this is how it will look like. Similarly, you can give row names also. So row names of x2, you can give some names. So single bracket or double bracket doesn't matter. What should I write? Let's say x, p. Okay, this is not allowed, I think. P, Q, or S. Row names of x2. No, quotes is not an issue, Disha. Quotes is not an issue. You see, I'll show you. It works with single quotes also. See, it worked. So now you have PQRS. I think this function, instead of row names, I think it's just names. Let me try just the names. Nope. I think there is no such function. You cannot give names to your rows. Yeah, there's no such function. Oh, it has 5 rows. Okay. Yeah, I missed that. It has 5 rows, right? PQRST. Now let me try. Yeah, it works. So you have that now, okay? So your x2 is this. Then I give column names to my x2. And then I give row names to my x2. And then I print x2. Okay, yeah, it works. So we don't usually use all of this in the industry, okay? This I'm just showing you to explain, but we don't ever use this. Okay, so this way you can give names also. Now once you have given names to your columns, now you don't have to, you can still use the previous indexing thing, but you can call variables by the names also. So let's say I can write now x2 and within quotes I can use p. So what will happen if I give this x2p? No, this will be column, right? A. Okay, it is giving me a na. I think the dollar works. No. Okay, we should be able to use the names also. So x2, no. No, it's not working. Okay, never mind. So we can use the normal indexing only. You cannot call them by using the column names. So you can still use. So if you want any particular thing, you can use, let's say x2, you can still use 2 comma 3. That will always work. Okay. So this is all about matrix. So why I covered matrix is not something which you will be using. X2, yes, I think it has to be like this. No, A is a row or is a column? A is a column, so it should be on this side. Okay, this, it should be quotation, I think. Just let me try one thing. I have never tried all this. Okay, S A. Okay, it is working in this way. Okay, so you can access using this also. You give the row number and you give the column number. Okay, and here if you leave blank, I'm sure it will give you all the columns. Yeah, it is working. So previously I think I had not given the codes, or I had given only the codes. So if I give only this, of course it will give any. Okay, so you can use the column names now instead of the indexes. You can, both will work now. You can either use the indexes now, but you also have names to your columns or names to your rows, so you can use the names also to access now. So if you want all elements in the row S, you can use this S like this, or if you want all elements in column, let's say A, you can use this also. Okay, so both options will work, indexes as well as the names. We usually use indexes, but you can use the names also if you want. So this is about the matrix. So clear, guys? Okay, so this indexing thing is very much used. Okay, so be very thorough with this indexing thing. The index, you should be very thorough with the index. Okay, so I will send an assignment this week where you will have to practice all of this. Okay, you'll have to draw histograms, you'll have to practice this. Okay. Okay, so far any doubts, guys? So what have we covered so far? So let me just note it down. So far we have covered matrix, indexing in matrix. Okay, these we are yet to. So I'll come to that later. Okay, so if you don't have any doubts, do you guys want a break now? We are halfway through the class. Shall we take a 10 minutes break? Okay, great. So let us take a 10 minutes break. It's 3:25 now. Let's reassemble at 3:35. Okay, so let's be back by 3:35. Okay, guys, I'll see you then. I don't smoke, by the way. Okay, so there's one more thing on vectors that we can discuss now is we can also subset a vector by giving some conditions. Okay, you can apply some conditions on a vector and select few elements based on that condition. Okay? So for example, let's say you have a vector called x. Okay, let's go to R and see. So let's say you have a vector x is equal to 1:20. Okay, and if you give a condition like this, so what will this give you? This will give you a boolean vector. The output of x greater than 3 will be a boolean vector. What will that give you? That will give you a series of true false for all the values of x. So what is the first value of x? The first value of x is 1. So is 1 greater than 3? False. That is why you see a false here. Okay. The second value of x is 2. Is 2 greater than 3? False. So you see a false here. Similarly, is 3 greater than 3? No, false. So false. Is 4 greater than 3? Yes. So you get a true, and so on. Okay. Oh, let me keep a small number. Then you will get like this. So does this make sense, guys? This makes sense, right? Guys, can you hear me? Okay. So you can do like this also. But let's say you don't want true and false. Let's say I don't want true and false. I want the value of the elements which are greater than 3. Or let me give some random values here. 3, 2, 6, 4, 11, and 12. Okay. Now if I run this, I will get false, false, true, 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 true. And let me give me a value 0 here. Now it looks good. It's totally random. So I have false, false based on the condition. Now let's say I don't want true or false. I want the values which are greater than 3. So I want 6, 4, 11, and 12 as the output. I want this vector as the output, this subset of the vector. I want all the elements which are greater than 3. I don't want true and false. I want all the elements which are greater than 3. Okay, so for that what you can do is you can put this entire thing inside square brackets and give x outside. Okay, see, if you run this you get the same. Okay, you can put this condition inside square brackets, so the output of this condition will be false, false, true, true, and so on. And whenever x false you write, it will give nothing. X false, it will give nothing. So it will only give for which you have true inside. So these 4 are true, so only those 4 will get printed because these 4 are true. The corresponding index is true. So only those indexes which are true will get printed. The remaining will not get printed. Okay. So this way you can do a subset of vectors. Subset vectors in this way also. Okay. I hope this was clear to everybody. This is very important, and the homeworks that I share will be on these. So you can give multiple conditions also. You can use and you can give multiple conditions. So let's say, for example, you give x is less than 3 and will not make sense here, or x is greater than, let's say, 10. Okay, you can do this also. So then you will get all the values where x is greater than 3 or x is greater than 10. Okay, similarly you can use ampersand also if you have to use the and operator. So I think this we saw yesterday. This is for and this is for or. Okay guys, so any doubts so far? Yes, you can use not condition also. So x is not equal, not less than 3 also you can use. So you can give x is, let's say, exclamation mark, not less than 3. Let's see if this works. X is not less than 3. No, it doesn't work. So x is not less than 3 is not working. Not equal to 3, this works. Okay, so not less than doesn't work, but not works with equal to. So it will not give you the values which are equal to 3. Remaining everything it will give you. Okay, why is it not working with less than equal to? Maybe we have to give it this way. No, it doesn't make sense. Less than 3. What if I write this? So I'm just trying something new. Okay, no. So with less than, I'm not sure what has to be used. Maybe I'll have to check that out. But it works with equal to. If you give not equal to 3 means except this, everything else will be printed. Okay. So maybe I'll give that as a homework so you guys can explore that. But guys, don't worry a lot about these things, okay? Because we'll be practicing this a lot in the future, so you will get to know this. Even if now it you might be thinking that there are so many things to learn, but as you practice, these things will become pretty simple for you. And you might forget a few things also, the way I have forgotten because I haven't used these small things for a long time. But that is okay. The moment you see R and the moment you use Google, you should be able to do. Yeah, you can do that. Maybe that is why they have not included Laditya, because giving not less than 3 doesn't make sense. You can instead use greater than sign. So maybe that is why they haven't kept that available. Okay, that totally makes sense. Okay, so this is on the subsetting part, how you can subset vectors and everything. Okay, now let us come to the stats part. Okay, so we will stop here on the R part. So we covered a new data type, which is matrices. So the matrices is not used widely. Okay, so we mostly use a data type which is called data frames. That is used a lot, both in R and Python. You use data frames. So most of the times we will be dealing with data frames. So what is a data frame? So matrix, you saw it was the same data type throughout, right? So data frames can have multiple data types, okay, but each column will be one data type. So data frame is equivalent to a SQL table. It is equivalent to a SQL table or a Excel spreadsheet, okay, where each column is a vector. Okay, each column is a vector. So you might have age, you might have employee ID, you might have employee name, you might have employee's income, and so on. So each column will have the same data type. That is what data frames represent, which we will see in the next week. So this is the data structure which you will be using almost all the time. Okay, so for all modeling purposes we use a data frame, but that we will see tomorrow. So matrix was just a prequel to data frames basically. Okay, it was just an introduction to data frame. I just wanted to go into 2 dimensions, so I taught you matrix, but matrix is not widely used. In fact, not at all used. We mostly deal with data frames, which will be similar to matrix in 2 dimension, but it will have multiple data types. But each column will be of the same data type. So each column is a vector kind of, you can say. Okay. So you might have age. So all values in age will be floating numbers. All values in employee ID will be numbers. All values in name will be characters. All values in income might be again floating numbers, and so on. Okay. So let's stop here on the R part and let's start with some statistics. Let's continue with the statistics. So I'm trying to keep the class very diverse so that you guys don't get bored. If I take 3 hours of R, you might get bored. Okay, and stats is also very important. So instead of covering all the stats on the same day, I'm trying to cover it in bits and pieces, in smaller installments. Okay, so now let us come back to our discussion of outliers. It is very important. Okay, identifying and fixing the outliers is very important. So we will talk a lot about our outliers, and we will see later why it is so important. Later, when we build machine learning algorithms, when we run algorithms, you will see outliers, they have a very bad influence on the algorithms. So we will have to identify them and treat them before we go to the model building stage. So what outliers we have already seen. Let's see how do we identify outliers. So far you have seen, let's say if I have numbers 5, 11, 9, 80 and 500. So which numbers here do you think are outliers? Is or are outliers? Which numbers do you think is a outlier? Yes guys, please respond. Okay, so Disha says 500 is a outlier, and Mrityunjay says 80 and 500 is a outlier. So that means there is a confusion. There is a confusion which is outlier. Some people say 80 is outlier, some say both 80 and 500 is outlier. So this confusion will always be there unless we have strict definition, right? Because so far I have not given you any definition that a number above certain threshold is an outlier. I have just vaguely told you that numbers which are very different from the others are outlier. But very different is a subjective term. Somebody may think 500 is very different. Some may think 80 is also very different. So it's a subjective thing. So let's give a number to that. So for that we use a box plot. What's called a box plot. Okay. This will be our second figure in R. The first that we saw was histogram. The next is the box plot. Now let us see what is a box plot. Okay. So a box plot looks something like this. Okay. Now you will have the values of the variable on the y-axis. Okay. The variable will be present on the y-axis now. X-axis there won't be anything. You won't have anything on the x-axis, and you will have something like a box here. Okay. You will have a box here. It is known as a box plot, or some people also call it box and whisker plot. I think there's a H here. Okay. These line that you see here, right? They are known as whiskers, and this is the box. So it is also known as box and whisker plot. Now let us see what does it represent. This is the variable. Okay. So the value here might be, let's say, 10. You might have some other values here. So these are the values of the variable. Okay. Now what does this represent? This represents the this starting of the box. It represents the 25th percentile. Okay. It represents the 25th percentile. The end of the box represents the 75th percentile. Okay. End of the box, it represents the 75th percentile. So now if you know these two, how much data do you have inside the box? Can you tell me? How much data do you have inside the box as a proportion? 50%, right? Everybody agrees to this? We have around 50% data, not around, we have exactly 50% data in the box, and 50% is outside this. Okay. So everybody knows this. 50% is inside the box and 50% is outside this. So this 75th percent, this 25th percentile is also known as Q1. Okay. Or first quantile. Q stands for quantile. That is known as Q1 or first quantile. 75th percentile is also known as Q3. Q3 or third quantile. Okay. I can also say third quantile. That is your this ending of the box, 75th percentile or Q3. So what is Q2 then, you might be wondering. Q2 is nothing but the middle of the box, which is the 50th percentile or median or Q2. Okay, that will be your this middle one. Okay, this is your 50th percentile. Okay, so all clear so far. So now still I have not told you that what is the threshold. I told you this is used to detect outliers. Now where are the outliers? Now whatever points lie outside these whiskers, you might get a few points here. Okay, these points are your outliers, and you might have something below. So these are your outliers which are very different from others on the lower side. These are the outliers which are very different from everything else on the higher side. These will be your outliers. So now you might be wondering, what is this whisker? So before I tell you what is that, this distance that you see here is known as interquantile range. Okay, Or if I write it in another way, what is interquantile range? Interquantile range is Q3 minus Q1, or 75th percentile minus 25th percentile. That is your interquantile range. Okay, so this distance is your interquantile range. And then you might be wondering, what is this distance then? What is this distance? So this distance is this point. You can arrive at this point by Q3. So this is Q3, right? This distance is Q3. Q3 plus 1.5 times IQR. Then you will get to this place. Okay. So till here it is Q3, and this distance is 1.5 times IQR. So this box into 1.5. That is your this distance. Okay. So this blue color is 1.5 IQR. Okay. And if you have to get till here, then you'll have to do Q3 plus this distance. Making sense, guys? Guys, is it making sense? Similarly, if you have to get to this distance, can you tell me now? What will be this distance? What will be this distance? Ravi, if you add something to Q1, you will go up. You will not go down. Agree? You are adding something to Q1. This is your Q1 you are adding. So you will go up. Yes. So you are right. So it is, this distance is nothing but Q1 minus 1.5 times IQR. Okay. On similar lines. Just the way you calculated this distance is also the same. This is also 1.5 times IQR. And if you have to reach here, you just do Q1 minus this. Because we don't know what is this, right? So the theory of statistics tells you that whatever is above this is an outlier, whatever is below this is an outlier. Okay. So if I have to write this down, I can write it in like this. So outlier means anything which is below Q1 minus 1.5 IQR, or anything which is above Q3 plus 1.5 times IQR. Okay, that is your outliers. So now you have a fixed definition to outliers. You can apply this definition and then check which is an outlier, which is a not. So that confusion won't be there. So you will apply on this data and you will see whether both 80 and 500 is an outlier or only 500 is an outlier. You can check that now. Okay. So let us do this in R then. So let me create some variables. So let's create a variable X. So we are into box plots now. Okay. So let me create x1, which is just some numbers from 1 to let's say 100. Okay. And let me create another x2, which is I'll intentionally give some outliers. Let's say I'll give minus 50. So minus 50 is like an outlier, and I'll give 1000. So I'm intentionally placing some outliers, x2, and then I will create x, which is nothing but combination of x1 and x2. Okay. So my x will have everything which x1 and x2 has, and then I will plot a box plot for this. So how do we do that? Very easy. Just write box plot. You see, I write box plot and I will write the vector which I want to plot. So box plot of x, and I will get this plot. So you see, I see an outlier. So this dot that you see here, that is the outlier. That means it is not considering minus 50 as an outlier. Minus 50 you don't see here, but 1000 is an outlier. Okay. So you know you have one outlier in this data, which is this point, which is this 1000. If I had kept maybe minus 500, then probably it would have been an outlier. So now if you do, you see two small dots. So that means minus 500 is also an outlier. So this way you can identify outliers in your data. Okay guys, is this clear? So this is a box plot, and you can give your labels here also the way you gave in histograms. So you can give label, main is equal to, you can give my first box plot. Okay, and similarly you can give your x labels and y labels also. So x label doesn't make sense here, y label only makes sense. You can write, let's say, age, whatever is that variable, you can write it down. Okay, so box plot is very important. So a lot of times you are asked in interview, so this can be one interview question. Okay, how do you identify outliers in your data? So you will say, I will plot a box plot, and then, so the moment you say box plot, they will ask you questions like this: what is a box plot? They will tell you. So you will have to explain this entire thing. That box plot, it measures basically. So you will draw this box and you will tell them that this is the first quantile, this is your third quantile, you have the median in between, and you have this interquantile distance, and whatever is above your q3 plus 1.5 times interquantile distance, or whatever is below q1 minus 1.5 times interquantile distance, is your outliers. So this is a very common interview question. You just will have to remember this, and you will remember. It is not very difficult also. So Devmita, why it is 1.5 IQR is the 50% of occurrences? Yes, Ravi. IQR is 50% of the occurrences. Yes, that's what you told, right? Everybody agreed to that. So this box that you see, the box has 50% of the data points, and the remaining 50% is outside the box. Okay, because you have 75th percentile here and 25th percentile here. If you subtract the two, you get 50%. Okay, and Devmita, why this is 1.5? I can only make a guess. So probably they did not want the outliers to be a subjective thing. Okay, they did not want the outliers to be a subjective thing. So they would have tested with lots of random values, and then they would have frozen this particular constant here. They would have seen that 1.5 makes more sense. Okay, so that is all I can think of. I don't think there is a reason to that. Yes, guys, any other question? Tell me. Okay, yeah, sure, Ravi. So what do we do in box plot? So till here it is pretty clear, right? I have just created a vector and I have intentionally added some outliers. If I don't add them, I won't see anything in the box plot, right? So that is why I have intentionally added the outliers here. And then I'm just trying to draw a box plot. So for that, the function is box plot only. So very easy to remember. You don't have to write anything else. Just write box plot and the vector. Which vector are you trying to plot? Which variable are you trying to plot? You just give that variable. And this is just heading. I'm just giving a heading here. So this is not mandatory. Okay, and when I run this, control enter, it gives me this. So this is telling me that there are two outliers in your data. One is this point, which is 1000. One is this point, which is minus 500. Okay, so this helps us identify outliers. So if I wanted, I could have, maybe if I give minus 5, this I don't think will be an outlier, so that won't appear. So that doesn't appear now. Okay, you have only one outlier now. So it tells you which point is your outlier. Okay, and now you know how to get rid of this outlier also. So if I tell you that create a new vector which doesn't have the outliers of x, how will you do that? So how will you do that? you will just write x underscore new, and that is equal to x where x is less than 500, because we saw that the outlier was 1000, right? The outlier was 1000. So you can give any value in between, maybe 200 you can give, or any value. So you can give 200 here. So x new will no longer have a outlier, because you have gotten rid of that value. You have only considered those values which are less than 200. So if you draw a box plot again of x new, you will not find the outlier now. See, there is no outlier now. You are getting a nice box plot. So you know how to identify an outlier. You know how to get rid of outlier also now. Okay, so these kind of questions I'll be sending in the assignment. Okay, Kundan has a question. After using box plot, we have to do manual intervention to check the outliers. Is there a way to do it automatically? Yes, Kundan, there is a way you can do that. You can automate that. We will see that later. Okay, once we go into data frames and all, we will see that later. So you can also calculate the quantiles. So see, I have, okay, let me tell you now itself. Yeah, so Vagish is asking a question. How can we check for 80 and 500? Now can we check for 80 and 500 for outlier? No, Vagish, I did not understand the question. Can you rephrase your question? Okay, you want to check for 80 and 500. Okay, from previous example, what numbers did I take? 5, 11, 9. Okay, let me check. So box plot of, let me directly write 5, 11, 9, 80 and 500. I think 500 will be shown as an outlier. Just 500. Yeah, just 500 is being shown as an outlier, not the others. Okay. So you can do this way also, directly giving the values. Okay. Now Kundan is asking me, how do I automate this process? Okay. So to automate this process, right now I am writing 200 here, right? So instead of 200, if you give a variable and that variable's value automatically changes, that means you have automated it. So for that, we will have to use a function called quantile. Okay. So what is quantile? It gives you any percentile that you want, any percentile. So of a variable. So let's say I want the 50th percentile. So I will give 0.5. If I do this, it will give me the 50th percentile, which is 50.5. So the 50th percentile of x. So we are talking about x now, which is this. X is this vector, which is 1 till 100 and minus 5 and 1000 also. So from this vector x, the 50th percentile is this 50.5. 50.5 is the 50th percentile. Okay. So what is this value? This is nothing but Q2. So I have got Q2. Similarly, if I have to get Q1, Q1 is nothing but quantile x 25th percentile. Okay. So I have got Q1 also. If you want to see its value, this is it, 25.25. Similarly, I can calculate Q3 also, quantile x 0.75. So this is your Q3. If you want to run this, this is your Q3, which is 75.75. And that makes sense also, because we had numbers from 1 to 100. Okay, so the numbers are very close to their percentile also. Now what do we have to do? We have to find that range from the box plot, right? So remember the box plot, this is the box plot. We have to find what where this ends, right? Whatever is above this is a outlier, is what I mentioned, right? Whatever is above this and below this is a outlier. So I have to find what is the value here. Similarly, corresponding to this, what is the value? So these two numbers I have to find. Now I can easily find that because I have all my quantiles. Okay, I have my quantiles, so I can easily find that. So what I can do, I can find IQR after this. So IQR is nothing but Q3 minus Q1. So this is my IQR. If I see, my IQR is 50.5. So now I can easily identify my outliers. My outliers are, so which are my outliers? So IQR into 1.5 plus Q3, right? So let me call it upper limit. Okay. Similarly, I will have a lower limit also. I will have a lower limit which is IQR into 1.5 Q1 minus IQR into 1.5. So this is my upper limit, this is my lower limit. Now I can give a condition, let's say x underscore new is equal to x, and I can use the ampersand now, or, and I can give the conditions where x is greater than lower limit or x is less than upper limit. So I'm deleting all the outliers basically. I'm keeping only the non-outliers. This will be your x new. So if you print x new, this is what you get. So you see, okay, I think it should be and, right? X is greater than upper limit. Yeah, it should be and, sorry. It won't be or, it will be and. Now you won't have, so the 1000 is gone. The 1000 was an outlier, right? When you draw the box plot, 1000 was the outlier. Now you have gotten rid of 1000 without doing any hard coding. There is no hard coding involved. You have automated the process. Okay, Kundan, do you understand? So using the existing information, we have automated this process. So you don't have to write these numbers. So this was hard coding where I wrote 200. So what if the data changes? If the data changes, 200 might not work. Okay. So what I have done is I have considered only variables here. There is no hard coding in these 4-5 lines. Okay. And this will get rid of all the outliers also. Is it clear, guys? Is this clear? Are these few lines of code clear starting from here? Tell me if you have any doubts. And this is the exact code that we use to get rid of outliers in the industry. Okay, this is the exact code that we use. Sometimes when we are in a hurry, we directly hard code it when we know that this project is only being done once. But when we have to repeat the project again and again, let's say it's a support kind of a project where the data keeps on changing, then you do something like this. You automate this so that it never malfunctions. But when you know you are doing it only once, you can do this also. Okay. This is very important concept. Okay, so whatever we have seen yesterday and today, from this you can expect at least one question in any analytics interview. At least one question you can expect. It can be either on histogram or it can be on box plots, but at least one question you will get for sure. Okay, so make sure these concepts are pretty clear. Watch the recordings again, and when you are watching the videos on YouTube, so most of the things will be repetitive for you. So what you can do, make use of the fast feature on YouTube. You can play it at 1.5 speed also if you want, or 1.25, or at double the speed, so that you won't have to spend another 3 hours watching the video. You can finish it in half an hour if you're watching at double speed. Okay, 1.5 hour. So make use of that feature. That will save time for you. Yes, Devmita, you can do. I'm sure there must be packages where this is already written, but we'll have to Google and find it out. But since it doesn't take time, we directly do this. But you can write a package also. Okay. So are you guys liking the coding process here in R? How is that? Are you finding it difficult or easy? So what do you feel about R? Yes, guys. What do you feel? Is R difficult or easy so far? It's easy, right? Yes, it is easy. Yeah. It will get slightly complex ahead, but not as you get in Java or some other language, okay? It will be pretty much this much. So if I have to just give you a gist of what happens in actual modeling, let me just show you. I was taking another class today, and this is what we did, okay, in the other class. So this is something which we did in the other class. We were trying to do some modeling, okay? So you might not understand that. Just to try to give you a gist of what we do in modeling. So we do something like this. We create some very cool visualizations, and that's what we do. So here what we were doing in this example, which is behind you, we were trying to identify the species of plants. Okay, so in the data we had three species of plant. One was Setosa, one was versicolor, one was virginica. Okay, and based on these features, based on the size of the flower, the petal length, the sepal length, the petal width, based on these three variables we had to tell which flower is which, just based on these three variables. So they will measure the size of the leaf, the flower's leaf, and they will ask us, tell me the species of the plant, and you have to predict the species of the plant. Okay, and this is what we got. So this is the output basically. So whatever these numbers you see, right, this is the accuracy, not this percentage but this number. This 1.00 means we were 100% accurate. So we were able to identify this species, the orange one, with 100% accuracy. Versicolor we got 98% accuracy. Similarly virginica we got with this much accuracy. Okay, so we will do some cool stuff like this later when we go to the modeling phase. Okay, and that is where the real power of R you will get to know. The real power of R lies in its modeling. So right now we are just building the base, which will help you later. But the real power of R lies in the modeling stage, and that is where, so the excitement will begin when you start machine learning. So that will be probably in towards the end of January. So next another 2 weekends we will spend learning R as a language, and learning the statistics which is required for machine learning. Maybe last weekend of Jan or February we will start with machine learning. Then the things will be pretty exciting. Okay, and that will be totally mathematics. Okay, now let us come back to what we were discussing here. Okay, let's talk about another variable which is very important in statistics. In fact, the most important variable of statistics, which is called standard deviation. So this is the most important variable of statistics. Not one of the most, the most. Now what is standard deviation? Now let's say I give you, some variable, okay? Let's say I draw the histogram of some variable. It looks like this. Okay, so the average will lie somewhere here. So since this does not have a tail, the average and the median will be almost the same. Okay, let's say the average is 50. It starts from, let's say, 10, average is 50, and it goes till, let's say, 80. And I have another variable. This is the histogram, okay, for some variable. I have the histogram of another variable. which looks like this. This starts from, let's say, 0 and goes till 100. Now what is the average of this red variable? What is the average? What do you think will be the average of the red variable? Yeah, close to 50, right? So here also you will have the average for this as well will be close to 50. And what about the mean, median? So the mean, median, everything will be same for the red and the blue one, right? Red and blue will have the same mean, almost the same mean or the median or the mode as well, right? Both red and blue will have the same mean, median and mode. But do you think these two are same? Do you think these two are same? No, not at all, right? They are not at all the same. Okay, so there must be some variable which will help us differentiate the two, because mean, median, mode is not able to differentiate the two. If you just look at mean, median and mode, you would say both are same. So there must be some variable which will define that this is different than this, right? That variable is known as standard deviation. Okay, that variable is known as standard deviation. So what it measures, you might have heard the word deviation, right? What is deviation? What is deviation? Something which varies a lot, right? That is deviation, right? Something which deviates. Okay, so which one do you think deviates more here? The blue one or the red one? Which deviates more? The red one, right? The red one is varying more. We all can see that the red one is varying more. Okay, so that means standard deviation of the red one will be greater than the standard deviation of the blue one. Okay, because standard deviation directly measures how much is a variable varying. Okay, so that variable which measures the variability of any variable is known as standard deviation. So standard deviation is a parameter which measures the variability of a variable. Okay, so what does it measure? It it measures the variability of a variable. Okay, higher variability means higher standard deviation. Okay, so this is what the variable means. Okay, okay, now this is what the variable means, but let us come to the actual definition of standard deviation. Okay, let us come to the actual definition of standard deviation. So first I will write the definition in English, and then I will write the definition in mathematics. So mathematics has a different definition, English has a different definition. Okay, so let's see the definition in English. So standard deviation is the first let me write it in mathematics, then it will be clearer. So in mathematics, if you remember mathematical notations, the sigma notations and all, your standard deviation, it is usually represented by sigma is equal to xi minus x bar whole square divided by n, summation of I goes from 1 to n, square root of everything. This is your standard deviation. Okay, this is the value of your standard deviation. Now I can write the definition in English. Standard deviation is the root mean square or RMS of deviations from average. Okay, is this clear, guys? So we will do an example where we will calculate this value, but standard deviation is the root mean square of deviations from average. So we talked about variability, higher variability, right? Ravi, guys, am I not audible? Okay, Okay, so we discussed that standard deviation means variability of a variable, right? So variability from what? Deviation from what? So deviations from mean. That is what we see. Okay, so we see here, for example, how far are they varying away from the mean. So if your mean is here, how far are they spread out? So you must measure the deviation from something, right? So that something is your average. So you measure how different are the values from the average. Okay, that's what you measure. So that is why that appears in the formula also. Standard deviation is the root mean square of deviations from average, and this is the formula. Okay, first you take the deviation. So this xi minus x bar is nothing but the deviation. Okay, and then you square the deviation, and then you divide it by the total number of elements present and take the square root finally. So this is your root mean square of deviations from average. Okay, any doubts guys so far? Yes guys, any doubts so far? Tell me. Any doubts in standard deviation? You must have doubts here, right? This is something which you are looking at the first time. So how come you don't have any doubts? So xi minus x bar. This is nothing but deviation. Xi minus x bar is your deviation. Okay. Then you take square of the deviation. Then you divide it by the total number of points that you have. Take the summation of it. I goes from 1 to n. And then take the square root of everything. This is your standard deviation. Okay. So you have to remember this formula. Okay, this is asked a lot in interviews. So how will you remember this formula? I will give you a cheat code for that. So if you just are able to remember the English definition, from the English definition you can easily get this formula. So what is the English definition? Let me write it again. Standard deviation is the root mean square. I'm writing just the short form. Root mean square of deviations from average. Okay, this is the English definition. So to get this, what you will do, you will start from behind. You will start from this side. So what is the first thing you do? You calculate the average. So how will you calculate the average? X bar is the average. Okay, here X bar is the average. Okay, average or the mean. So how will you calculate X bar? It is just adding everything and dividing by n. So that will give you your average. So you have your X bar. You have calculated it here. After that, what do? You see deviations from average. So that means now you will have to calculate deviations from average. So how do you calculate deviations from average? You take each point and subtract the average from there. So you will get the deviations from average. Okay, so this will give you the deviations from average. After that you move ahead. Now root means square, so then square, so that means you have to square it. So you take the square. Then mean, that means you take the mean. Okay, and then the root, so you take the square root. This is your standard deviation, and of course you will have a sigma here. Okay, so you got the definition, the mathematical definition, if you remember the English definition, and very easy to remember. Root means square of deviations from average. That is the English definition. Okay, okay, let's do one thing, Jagdish. Let's calculate this, then it will become very clear to you. So I'll give you a vector. I will give you a vector. Let's say I give you age. Let's say I give 5, 10, 15, 20, 32. I have given you 5 values of age. All you have to do is calculate the standard deviation. you will have to calculate the standard deviation for these 5. So can you guys try this on your own? I hope everybody has a notebook, right? Guys, please, when you're attending the class, have notebooks and a pen. That will help you. Okay, because this is not a coding course. Okay, coding course you won't need a notebook. This is more of a maths and a stats course. Coding is just what we use to calculate a few things. So always have notebook and pen where you can do rough and do some calculations. So can you use this formula and try to calculate this? Can you try to calculate standard deviation for this? And then maybe I'll tell you how is it done. So try if you can on your own. Meanwhile, I'll get some water and come. Wow, everybody is getting a different answer. Looks like a bidding is going on. 2, 9.6, 23.97. Anybody who wants to bid higher? Okay, let's see. Have you taken the square root at the end, Vagish? Because 23 is too big. I think you missed to take the square root. Okay, let's see. So let me write down the number here. So let's say x is the variable. So let's say this is age. So let's say age, I will have 5, 10, 15, 20, 32 here. Okay. So the first thing that I have to do is to calculate the average. No, Vagesh. See, you'll have to square everything and then add. So this has to be done in a sequence. Okay, let's see. I'll tell you. So the first thing that you have to do is calculate this x bar. Okay. So what is x bar here? 5 plus 10 15 plus 15 30 plus 2 50 plus 32. 82 divided by 5. So 82 by 5. 5 ones are 5. 5 6 is 30. 5 4 is 20. So this is your average. Okay. Now what you have to do is you have to subtract all the values. Xi means each of the value. I is equal to 1. So here I is equal to 1. I is equal to 2. I is 3. I is 4. I is 5. This is all your I. So 5 minus 16.24. You have to do that. So 5 minus 16.24. How much will you get? Okay, 11.24. I think you can do this easily in Excel. So minus 11.24. Similarly, 5 minus 10. No, 10 minus 16.24 is minus 6.24. 6.40, sorry. Okay. 15 minus 16.24, 1.40 minus. 20 minus 16.34, 3.60. Okay. This is 15.40 and so on. So you will get these values. So this is nothing but xi minus x bar. This is that value. Now what you have to do is xi minus x bar whole square. So you have to square these terms so that the negatives will become positive. So if you square 111, you get around 121, 36. 1.4, you get around 3. 3 3s are 9, or maybe around 10 you will get. 15 to 30 is what you will get, around this number. So you have these ready now. Now what you have to do, you have to take the sum of all of this. That's what I have done, right? First you have to calculate this. If you jumble the order, you will get a totally different answer. Now you have to take the sum. Okay. So now if you take the sum of all of this, you will get some number. Now that number you will divide by 5 and finally take the square root. Okay. So that's what you will have to do. So approximately if you calculate, it will be 121 plus 36 plus 3 plus 10 plus 230 divided by 5 and square root of this. So 8.9 or maybe around 9.6 you will get. I did not calculate the squares correctly. You will get around 9. So I think 9.26 is the correct answer. Okay. Everybody agrees? So if you do that, you will get 9 point something. So close to 9 is the answer. So 9 is the standard deviation of this. We can do this in R as well. Let us do this in R. So 5, 10, 15, 20 and 32, right? Let's do that in R. Standard deviation. Okay. So our age is, what are the numbers? 5, 10, 15, 32. One more, right? 5, 10, 15, 20 and 32. 20 and 32. You find the standard deviation using the function SD. So if you give SD of age, you will get the value of standard deviation. But here you will get a slightly different value. I'll tell you why. Okay. So this has this there is a statistical reason why you are getting 10, because in R what is done? In R uses n minus 1 instead of n. Okay. Instead of n, R is using n minus 1. Why is that? That I will talk later. That has its roots into deep statistics, which is for another lecture, not today. But that is what R is doing. R is taking n minus 1. So how will you get the answer for this? You can just multiply it by square of n minus 1. So n minus 1 is 4, that means 16, and then divide it again by 25, right? No, 25 or how many? How much? So you have this. So the SD which R is calculating is whatever SD we have, but it has n minus 1. And let's say this is your x. Okay. So to get rid of this, we will do SD whole square is equal to x divided by n minus 1. SD whole square into n minus 1 will be your x. Okay. And that x you will take and again divide it by n and take the square root. Okay. So that's what you will do to get the correct answer. No, Lalitya, I did not mention why it is using n minus 1. That is a detailed discussion which is for another lecture, not today, because that has its reason in some theorem of statistics which will come later. So if I tell you now, you will not understand. That probably we will cover in the next weekend or the weekend after that. So we'll have to go through a few theorems to come to that. Okay, but this is the correct formula. This is the correct mathematical formula. R uses n minus 1 for a reason. So just to give you an intuition, if you are dealing with a population, okay, if you are dealing with a population, the formula is n. Okay, whatever above thing is the same, you use n. But if you are dealing with a sample, then you use n minus 1. If you are dealing with a sample, so R by default assumes that we are dealing with a sample, because R assumes that the data might be huge. The data is huge, so you cannot collect the entire population's data. That is by default R assumes. But right now I did not tell you anything about that, right? Population and sample. So you will use this n only. So that is why you are getting a slightly different answer. And instead of 5, if you divide it by 4, so whatever values you got 9 point something, right? 9.26. So imagine if you had divided it by 4 instead of 5. So here R has divided by 4. That is why R is getting a slightly bigger number, because you are dividing by a smaller number. So you are getting around 10, which is correct, which makes sense also. Okay. But this is not correct. This is also correct if you are using a sample. But I did not tell you that this is a sample. I told you this is a population. So you will have to use n and not n minus 1. So this is the correct answer. Okay. So 9.36 is the correct answer. Jagdish, is this clear? Now standard deviation, is it clear? And honestly, if you have very big number, it doesn't make a difference whether you have n or n minus 1. Okay. If you have too many numbers, let's say if you have 1000 numbers, if you have 1000 data points, you divide it by 1000 or you divide it by 999, doesn't make much of a difference. Okay. Because whatever you have here is a square. It's a very big number. So that big number, you divide it by 1000 or you divide by 999, it won't make much of a difference. So you will get almost the same value. It is just the sum. Yes, Jagdish. It is just the sum. Okay. So first you will do this and just the sum. So just remember the English definition. Just remember RMS. Root means square of deviations from average. So first you calculate the deviations, which is this. Then you square it. So you square it. That's what I did, right? So that's what I did. First you calculate the deviations. So this is your deviations. Okay. Then you square it. So RMS. So deviations, then you square it, then take the mean, square it, then I have taken the mean and then taken the square root. That's it. Just follow the English definition and you will have it. But don't worry, you don't have to calculate SD ever. You'll always use the software for that, but you should know the formula basically. You should know the formula, okay? Because this is the base of statistics. But you won't have to calculate this ever. So you just use the function SD and you will get the answer. But you should know the formula. Okay. So guys, I think that is all I had for today's class. Any doubts if you have, you can ask me now. Okay. And there is just one another variable that is often used. There is a variable called variance. Okay. And what is variance? It also measures the same thing as standard deviation, and its formula is standard deviation whole square. That is variance. Both measure the same thing. So variance and standard deviation, they both measure the variability of a variable. Measure the variability. Okay. Variance has units whole square, and standard deviation has the same unit as the variable. So if we are talking about salary, the units of variance will be rupees whole square. Okay, because it's square of standard deviation, and the units of standard deviation will be rupees. Okay, so just remember this. So standard deviation is more commonly used than variance because it is interpretable. You can directly understand, but variance, it is very difficult to understand because it is units whole square, so it doesn't make sense actually. Okay, so application of this will be, you might have, let's say, income of, let's say, so a few companies, if you see, let's say income of IT professionals from, let's say, 5 to 6 years of experience. Okay, if you are working at a good company, if you are working at a good company which has solid work culture, the standard deviation of income of this bracket will be small. Okay, but if you are working in not a very good company, I won't say not a good company, but a company which basically promotes, which doesn't give much weightage to your experience, there somebody, even junior, might earn a lot, or somebody might earn very small amount. So it can happen anything. They won't have any benchmarks basically, that this is a 5-year-old guy, I must pay him that much. There is no benchmark like that. So there the SD will be big, a large number. So do you get this example? So SD is small means everybody is very close. Everybody earns almost the same amount in this experience. Okay. But if your SD is big means there is a huge variance. So somebody is earning 3 lakhs with 5 years experience. Somebody is earning 15 lakhs. But here the difference will not be a lot. Okay. So it will be maybe between 5 to 8. Everybody is earning between 5 to 8. But here the range is big. So that means standard deviation is large. Okay. Or another example, if I have to give you, let's say you are a stock purchaser, you invest in stocks. Okay, yeah, this is a better example. You invest in stocks. How many of you know how the stock market works, or at least know how the stock, you buy stocks and when the price rises you sell it, right? And sometimes the price falls also, then your money is stuck. You either have to sell it as at a loss, or you wait for it to increase again. Okay, so let's say this is the histogram of a stock price. Okay, let's say these are two stocks and these are the histograms for that. So this is the stock of, let's say, TCS. This is the stock of, let's say, ITC. So which stock will a person prefer if he has high risk profile? Okay, if he has low risk profile. High risk profile means he is ready to take high risk to earn good amount. Low risk profile means he is not ready to take a high risk. Okay, so which stocks will they prefer? Who will prefer TCS and who will prefer ITC? And this variable is, by the way, price of stock, price of the stock. High risk profile is TCS, and okay, one is TCS, one prefers TCS. So that's what everybody is telling. High risk profile is preferring TCS. Okay. What about the others? What do you think? By the way, in terms of standard deviation, which one has higher standard deviation? So standard deviation of TCS and standard deviation of ITC. Which one is higher? TCS is, ITC has higher SD. Okay. So ITC standard deviation is high. For this, it is low. Yeah, that is true, Lalitya. So now who will prefer what? High risk profile will prefer TCS is what you are saying? Okay, high risk profile TCS, and this guy will also take TCS, or he will take ITC. So is this correct? High risk is high standard deviation. So that means this is wrong, Lalitya. So that means this is wrong. Okay, what about the others? What do you think? So which is the answer? 1 or 2? Which is the correct answer? Lalitya thinks it's 2. Okay, so let's say the average price of both stocks is the same. Let's say it's 50 rupees. Average price of both stocks is 50 rupees, but TCS can go from 40 till 60. Yes, I think you guys are getting it slowly. So yes, this is the correct one. So Lalitya and Mitunjay, you guys are right. Okay. So let's see why. It is very logical. So TCS, it varies only from 40 to 60. The average is 50. Okay. ITC is also average is 50, but it varies from 10 till 100. You see that, right? You see that on the screen right now. ITC has a higher variability. Standard deviation is high for ITC. That means it can vary more than what TCS varies. Okay. So that means if you are buying the stock at 50 rupees, if you are buying TCS stock at 50 rupees, maximum you can benefit is 60. So 10 rupees you can benefit, or loss also you can have a loss of 10 rupees. You will not have a loss beyond that because it is never going after that. But if you buy ITC at 50 rupees, sometimes it can also go to 10 rupees. So the losses that you can have might be huge, but at the same time the profits can also be huge. So from 50 it might go till 100. So high risk profile means this guy is okay to take risks. So that means he will prefer ITC because he wants to take risks. He has a high risk profile. So he can take the risks. Okay. He can take the risks of going till 10 rupees, but he will try to maximize his profit. So he will prefer ITC stock. And what about the TCS? TCS is pretty stable stock. It does not vary a lot. It hardly has plus minus 10% variance. So that means a low risk profile will prefer TCS. He will not want a very high income at the cost of a high risk. So he will prefer TCS. Is this clear, guys? Is this example? Everybody? So Disha and others who gave the wrong answer, is this clear? Okay, so this is a direct usage of standard deviation. So stockbrokers, they do look at standard deviation of the stock when they recommend a stock. Or if you guys are investing in stocks, you should look at standard deviation of the stock. How much does the stock vary? Okay, you should look at that and then accordingly pick. If it varies a lot, that means it's a risky stock. If it doesn't vary a lot, it's not a risky stock. Okay, so that standard deviation or variance both measures the same thing. So that is very important. Okay guys, so this is a usage of standard deviation or variance. So I think that is all I had for today's class. Any doubts if you have, you tell me, or I will start revision now. Yes, so standard deviation measures the width, Mrityunjay, you're right. Okay. Yeah, in the stock is the width. Height also is important. Okay, the height determines how stable is the price. Height means if it is very high means most of the time it is at that price. Okay, if the height is very good, that means at most of the times it is at that particular price. Okay, so let's say you have a height like this. Okay, and somebody has a height only this, and it is like this. So this means that let's say this value is 100. That means 100 days in a year. The price of this stock is whatever this price is p. 100 days in a year. But if the height is small, if the height is only this much, that means only 10 days in a year the price is this. Only 10 days the price is p. So height is also important. So height measures how many days was this particular price, or how many weeks, or whatever that variable is, how many times was that price present. And this measures how it changes. Okay, if it changes, in what range does it change? Does it change only like plus minus 2 or plus minus 10 or plus minus 100? So how does it change? The stability of that. Okay, so for TCS example, fluctuation is more in less time, so it isn't risky. Yes, it is not risky because the fluctuation is very less. It can vary only from 40 to 60. So though you may not gain a lot, but you will not lose either. Okay, most of the times the price will be 50. For ITC also most of the times price will be 50, but it varies a lot. It can go 10, sometimes it can go 100, though most of the times it will be 50 because this value is highest, right? This value is highest. That means most of the times it is 50, but sometimes it might go to 10 also, and sometimes it might go to 100 also. So a guy with a high risk profile might be waiting for the time when it goes to 100 and sell the stock so that he gains 100%. But it might go to 10 also. Then he might lose a lot. Okay. Okay, guys. So let's start revision now. We'll do in the same page. So what did we cover today from the beginning? Can you help me? Yes, guys. What was the first thing we covered today? Yeah. From data structures, we covered matrix. So what is a matrix? Similar to vectors, but in 2D. Why I say similar to vector? Because it takes only one data type. Okay. So it is defined using the matrix function. You give the values that you want. Let's say you give 10 to 20, and then you give the number of rows that you want. You can give number of columns that you want, and you can give by row is equal to true. Okay, these two things are optional. So this one and this one, whatever I have written in green brackets, they are optional. If you don't give them, it will still work. It will take some default value. So by row by default will take false. That means it will fill the columns first, and number of columns if you don't give, it will automatically calculate, because it knows that number of elements is equal to rows into columns. So if you give this, only one will be required, both is not required. Okay, so that's about a matrix. Let's say you define a matrix like this. This is a matrix that you have got. How can I print this entire first row? How can I print the entire first row? Yes, Jagdish, the third will be data frames. Yeah, so to print this entire row, what I will do, I will just write the name of the matrix, assuming it is X. I will just write row number 1, and columns I will leave blank. Okay, if I leave columns blank, that means it will print all the columns for me. Okay. Okay guys, if I want this 9, I can write 2 comma 2. That means second row, second column. So the syntax is row number comma column number. If you leave anything blank, it assumes you want all of them. Okay, if you leave row number blank, it means for that particular column you want all the rows, or for that particular row you want all the columns if you leave with blank. Then we saw you can also have names to your matrix. So we saw the example A, B, X, Y. You might have something here, right? So 0, 1, 9, and let's say 11. So you can also access these by, so let's say if you want to access 0, 1, you can also access by just giving the name of the row. Leave it blank. Blank means it will give all the elements present in that row. Now since it is a name, right? These are column names, these are row names. You will have to use the colon, not the colon, the quotations. Okay, you'll have to use the quotation. Similarly, if you want 11, you'll have to write it is in row number Y, not number, row name Y and column name B. So you will have to use this to get 11 out. Okay, so this is what we saw in matrices. And how do you give column names to your matrix? You just use the function call names. Call names, name of the matrix, and you give how many columns you have as a vector. As a vector, you pass the column names. Similarly, you can give row names also. So row names, the name of the matrix, and as a vector, you pass as many values as the number of rows in the matrix. Okay. Anything else in matrix, guys? Yeah. Then we saw how to get subset of vectors. Okay. We saw how to get subset of vectors. If you have a vector, if you want to if you want only some particular elements out as a condition, you can always give x less than, or whatever condition it is, less than, let's say 5. If you give this, what will be the output? If you give this, you will get a series of true falses. You will get a boolean vector. You will get a vector whose data type is true and false, a boolean vector. But if you want the elements, if you want the values to be printed, you just put them inside square brackets. You just put them inside square brackets and you will get the corresponding elements. To get the corresponding elements. Okay. Because if you do this, let's say if I do this, true, false, true. Okay. If I give this, only at those indexes where it sees a true, it will print. Okay. It will print only those indexes. So if x is, let's say 1, 5 and 11. Okay. If this is my x and if I write this x, see true, false, true, it will only print 1 and 11. It will not print where it sees a false. So 5 will not be printed. It will only print the true. And the moment you give a condition like this, it is indirectly giving a series of true and false. Okay. So it will print only the trues and the false it will not print. So that is how you subset a vector. Okay. What else? What else, guys? Okay. So next we came to box plots. Intro about data frames, that was just a heads up. So we will go into details in the next week. So let's not go into data frames. Data frames are just collections of vectors. So each column will be a vector, and when you combine 2-3 columns like that, it becomes a data frame. So it is like a SQL table or a Excel spreadsheet. Okay. So this Excel spreadsheet, for example, is a data frame. So it has different columns. So for example, this column has characters. This column also, this column has data type date. So these are all dates, you can see, right? These are all dates. So this column has a data type date. This column again character. This column has numbers, the number of hours. So these are all individual vectors, and when I combine them, this 2D table that you see is a data frame. This is exactly what a data frame will look like. Okay, each column will have the same data type. So in this column, all the places you have characters. Here all the places you have date. This is just the column name. Okay, here all the places you have characters. Here all the places you will have numbers. I will not write th some other name here. It will always be a number corresponding to the number of hours of class. Okay, similarly this might be always the time. So that will be a data frame. Next we saw what is a box plot. So what is a box plot? What is its usage? A box plot is used to identify outliers in your variable. Okay, how does it look like? It looks something like this, also known as box and whisker plot. It will look something like this. So this is your Q1 or 25th percentile. Okay, this is your Q3 or 75th percentile. This distance is known as interquantile range, and you have your median in the middle. This is your median, or Q2. Median is also known as the second quantile. You have 50% of your data in your box and 50% outside the box. Okay, so if you have to measure where are your outliers, you have to reach. So this y-axis is your variable. Okay, so you have to reach to this point. So how will you reach to this point? This is nothing but Q3 plus this distance. And what is that distance? This distance is 1.5 times interquantile range. So this distance is 1.5 times IQR. Similarly, this distance is also 1.5 times IQR. So how do you reach till here? You just add this distance to this Q3. So pure geometry. So Q3 plus 1.5 times IQR. So you have reached here. So whatever is above this, you might have a few points above this, they are outliers. Similarly, whatever is below this, you might have a few points here which are outliers. So this point is nothing but Q1. So you are here minus this distance. Q1 minus 1.5 times IQR. So you can say outliers are all the points which are above Q3 plus 1.5 times IQR or less than Q1 minus 1.5 times IQR. That is your box plot. Okay. Is it okay, guys? Box plot. And we saw a way how to automate this process. Instead of writing exact values, we can also give Q1, Q2, Q3 as variables. And you can easily filter out the outliers from a variable. Okay, you can omit the outliers from a variable by using the same formulas that I have written here. These same formulas will work. So whatever I wrote here basically. So these formulas. Okay. What else? After this, what did we cover? Yes, guys. I'll take another 4-5 minutes just. Okay. So after this, we came to standard deviation, right? We came to standard deviation after this. So what is standard deviation? It is root mean square of deviations from average. Okay, root mean square of deviations from average. So this is the English definition. If I have to write the mathematical definition from here, first I will calculate the average. X bar, the average is represented by X bar. I will calculate the deviation. What is the deviation? Xi minus X bar. So deviation of each point. Okay, each point from the average. So each point, how far is it from average? So that you will get from this subtraction. Then the definition says you square it. Okay, so I will square it. Then it says you take the mean. So I will take the mean. And then it says you take the square root. So you take the square root. And this will be a summation here. So 1 to n. So this is the formula of your sigma or standard deviation. And what does standard deviation measure? What does it measure, guys? Lalitya, it doesn't matter. It is x bar minus I or xi minus x bar. It doesn't matter because you are taking a square of it. Okay. So and both will give the same answer. Okay. Yeah. So the Mita, you are right. It measures the variability of a variable. Okay. So standard deviation measures the variability. It measures the variability of a variable. How is the variable varying? So remember that example which we took, the stock price. If the histogram is very wide, that means it varies a lot. It will have a high standard deviation. And why are we discussing standard deviation? Because a lot of theorems in statistics are based upon standard deviation. So we will see all the theorems as the classes proceed. A lot of theorems are based on standard deviation. Okay. So that is standard deviation. Then we saw another parameter called variance, which is nothing but square of standard deviation. That is called variance. Standard deviation has the same units as the variable. Variance, since you are squaring the standard deviation, the units also get squared. So it will be square of the units. Okay. Anything else? Anything else, guys? Okay. So this is pretty much I had for the second day's class. We did not cover a lot, guys, but it was important to start the classes slow so that you guys feel interested about the topic. Only if you are interested in this, you will be successful in this. Okay. So I will try to give some very good examples which basically will create your interest in this subject. And this subject is interesting. Okay. If you like to understand businesses, if you have liked mathematics in the past, you will like machine learning. And whatever you do will have direct implication on your businesses. We will see that when we start with the case studies. You will see whatever you are doing will have direct influence on the businesses. When you are in information technology, when you are doing software engineering, when you are creating websites or doing ETL or doing SQL to a database, writing SQL queries, that doesn't have any direct influence on your business. But whatever you do now will have direct influence on your business. And that is why not only engineers, but more than engineers, you will have MBA people into machine learning. You'll have MBA guys who have done their MBAs. They will be learning machine learning. So most of my students are MBAs, in fact, because they are closer to business, and their job is to directly influence the business. So engineers, they are more technical people, but there is a lot of technology involved in machine learning also. It's basically, it deals with all the algorithms, so it is fully technical, but you need a lot of business domain as well. So people who have more experience, so they will have to make use of their business understanding. So people who with more than 8 plus, so 8 plus years experience guys in this batch, so make use of that experience that you have, whichever domain you worked, be it finance, be it CPG, retail, whatever. So that experience that you have, that domain knowledge that you have will come handy.